Hello everyone, my name is Angela Simonovska and today I'm going to present the work related to an electrical model-free optimal power flow for PV-rich low voltage distribution networks. This work has been done in collaboration with my colleagues Vincenzo and Arthur, as well as my professors Namdel and Tansu. So with the growing uptake of distributed energy resources such as solar photovoltaic PV systems, they are creating a lot of voltage rise issues as response to the changes in net demand. So distribution companies try to deal with this problem, and one of the potential solution is the DER orchestration or the active management of the PV settings of customers' PV systems. The conventional techniques such as the AC OPF requires detailed low voltage models such as knowing the topology, the impedance and connectivity, which in most of the cases is not available. Therefore, this work proposes the optimal calculation of PV settings by using, instead of power flow equations, a neural network which is trained to capture the nonlinear relationship among historical smart meter data. In other words, we propose an electrical model-free OPF. So we take the active and reactive power of the customer smart meters and use them as input to a neural network, whereas the voltages are used as output of the neural network. The neural network is firstly trained, and then its equations are used in the electrical model-free OPF formulation. The objective function of the electrical model-free OPF is to maximize the active power of the customer's PV systems by taking into consideration the maximum available PV generation, as well as the equations of the neural network, and finally the thermal and voltage limits. As for the case study, an Australian low voltage feeder with 31 single phase customers are used. Three datasets are taken into observation. Firstly, to assess the performance of the neural network, the training and testing dataset with 60% of PV penetration, when with the low voltage feeder doesn't experience any voltage issues, is considered. And to obtain the performance of the optimization problem, a testing dataset with 70% of PV penetration, where the low voltage feeder experiences voltage issues, is considered. So the neural network performance is obtained by checking the mean square error, the average, and the maximum voltage deviation. The values are very low, therefore the neural network achieves a very accurate performance. In terms of the calculated PV settings, which is compared with the AC OPF, we can see that the model-free OPF underestimates the PV generation or curtails more than the AC OPF. This curtailment is up to 4.5%, which is not that high. In terms of the voltage profiles, we can see that the model-free OPF actually resolves the voltage violation such that there is no non-compliant customer. However, since it underestimates the curtailment, or in other words, curtails more, the voltage profiles as seen by the real low voltage network are a bit lower. Therefore, we can conclude that the proposed electrical model-free OPF shows promising results and can be used by distribution companies to perform DER orchestration without the need for electrical models.